Do you see my presentation?
Yes.
Good afternoon, dear Chairman and participants of the conference. My name is Kapravchuk Vladislava, and I want to introduce our study, Amplitude Parameters of Electrical Impedance Myography with a Different Pressure of the Electrode System Research. Bionic control systems are implemented by a neuromuscular interface, which is an intermediate link between the body and the equating mechanism. The key moment is the choice of a method for obtaining information about the movement performed by a limb, which makes it possible to determine its type and perform a numerical estimate of the force moment characteristics. Electrical impedance myography is a promising concept, but requires further study methods. The purpose of this research is to study the influence of amplitude parameters of electrical impedance myography at various pressure of the electrode system to the skin surface. Electrical impedance measurement is a non-invasive method for determining the electrical properties of tissues. This method consists of placing a high-frequency probing current between current electrodes and rejecting the arising potential different at the measuring electrodes located in the projection area of a muscle or muscle group that are active during action. The measured values of electrical impedance carry information about the electrical properties of biological tissues at the depth of probing. Muscle contraction leads to a change in the electrical impedance signal. This is a consequence of morphological and electrophysical changes in the parameters of the sensing area. Uncontrolled pressure of the electrode system has a significant effect on morphological change associated with motor activity. It can also lead to errors in recognizing the type of the action and a decrease in the quality of proportional control. Stable contact of the electrode system with the measurement area can be achieved due to defined pressure force of the electrodes. In case of insufficient pressure, there may be distortion in the position of the electrode system associated with thicknessing of the muscles during construction. This can lead to adverse artifacts or complete loss of contact of the electrodes with the skin surface. Excessive pressure is unacceptable as well as it also leads to distorted result, discomfort for person and the inability to use the system for a long time. Thus, an important task it is to determine the acceptable contact pressure of the electrode assembly and it is allowed to carry out measurements that are comfortable for the volunteer with sufficient accuracy to generate control commands for the executive device. To control the displacement and pressure force of the electrode assembly to the skin surface and register electrical impedance myography, a laboratory test stand was assembled. The laboratory complex included a pressure stand, a side-to-side device for bioelectrical measurements, and a mechanical signal conversion device. The pressure stand included stepping motors for precise positioning of the electrode system in the horizontal plane relative to the measurement area and for vertical movement in order to realize pressure. The pressure force value was recorded using force sensors. An optical encoder was used to measure the vertical displacement feedback. The electrode system was installed by means of special fasteners on a construction with force sensors. The electrodes, the form of a circle with a diameter of 7 millimeters, were equidistant from each other by 10 millimeters. To perform the action with the force, a wrist expander with a preset load of 10 decanewtons was used. The technical characteristics of the complex are presented in the table on the slide. To determine the dependency of changing amplitude parameters of electrical impedance myography on the pressure force of the electrode system during the grip of the wrist expander, measurements were made on 10 healthy volunteers. The object of the study was the upper third of the volunteer's forearm with a girth of 20 to 35 centimeters. The volunteer forearms were positioned in the pressure stand. Then the operator positioned the electrode system by pressing it to the skin until contact appeared. Before the measurement, contact electrode paste was applied to the electrodes to reduce the electrode skin resistance. The recording of the electrical impedance signal was consistently carried out in the area of projection of the antagonist muscles. During the measurements, the volunteers circularly performed the grip of the wrist expander, after which the electrode system pressure force was iteratively increased. Example of the signals measurements in a single study is shown on a slide. Analysis of the absolute values of electrical impedance shows that when the pressure force is in the range of 0.2 to 0.5 decanewtons, the dependence of the amplitude of electrical impedance on the pressure force reached a plateau. The parameter delta R was investigated. It was calculated as a difference between the electrical impedance at rest and during action. The delta parameter reflects the change in the amplitude of the action pattern in the electrical impedance signal. At low electrode pressure forces, up to 0.2 decanewtons, high values of the parameter delta R are observed. However, the signal is unstable at the slightest change in the pressure force of the electrodes. In order to avoid signal instability, the pressure force of the electrode system must be in the range from 0.2 to 0.5 decanewtons. In this range of pressure force, a pronounced and reproducible change in the signal is observed when performing actions. A further increase in the pressure force leads to the fact that the parameter delta R is extremely small values. As a result, it is quite difficult to identify movement patterns. The process of using devices such as prostheses, ortheses, bracelets to control devices in everyday life has one important problem for developers. It is constant change in the pressure force of the electrodes during the use of the device. The electrode system pressure force can influence on the electrical impedance signal and the action pattern in the signal. To ensure proportional control, it is necessary to work with a stable signal, the change of which will slightly depend on the electrode system pressure force when performing action. As a result of the research, it was determined that there is a range of electrode system pressure force at which a stable contact of the electrodes with the skin is ensured, discomfort does not arise, and a stable electrical impedance signal is provided. Movement patterns in this range do not depend on the electrode system pressure force. For healthy volunteers, the range was from 0.2 to 0.5 decanewtons. Designing control systems based on this result will provide proportional control, prevent the formation of erroneous commands, and improve the quality of device control. Thank you for your attention. I'm glad to answer your questions.
Thank you very much. How you perform statistical analysis in your study? You have 10 volunteers, it's a small group, and you use methods of ECG processing, or sorry, not ECG, but impedance processing. Why do you analyze sensitivity and some statistical properties of your approach?
We will do this in future. In future for more volunteers, and for this research we analyze these signals with MATLAB, and when the signal is good.
Okay, thank you. Maybe other questions from our colleagues? Okay, in this case, we go to some break. If you want, we can discuss something. Anton, are you ready for discuss something? Maybe you want to you take participation. I propose to. Okay, I start screen. Sorry. Yes, start screen with break. But maybe we want to discuss some topics. Anton, you have a discussion on round tables about ophthalmology. Maybe you explain, maybe you say something about this event and what's happened, what's result after.
Well, this event was quite interesting. Well, it was, people of a very, different topics, different specialization, I must say, but, this topic of, ophthalmology and biomedical engineering is, by design multidisciplinary, so it was very nice. So there were guys from Bauman Institute who were doing the model